Hello, and welcome to this Bitwise webinar on efficiently migrating your on-premise data to the cloud. My name is Nathan Nichols, Head of Partnerships here at Bitwise, and joining me today is our very own Dhananjay Shind. Dhananjay is a BI solution architect who brings over 8 years of extensive experience in designing and developing BI solutions and delivering end-to-end BI implementations. Before I pass things over to Dhananjay, let me first provide a quick introduction to Bitwise. Bitwise, a global technology consulting and services company, uses over 23 years of enterprise data management experience to help bridge gaps between traditional EDW and cutting-edge technologies, including big data and cloud. What truly sets Bitwise apart is our technology leadership in creating unique accelerators and frameworks that reduce the time, complexity, and cost of large-scale initiatives such as cloud migrations. Bitwise is headquartered in Chicago, Illinois, and we have our UK office in London with global delivery centers in Pune, India. Just a quick note, we will have Q&A at the end of this session. So if you have any questions during the session, feel free to send those via the question feature, or you can contact us at any time at sales@bitwiseglobal.com. And with that, I'd like to pass things over to Dhananjay. Dhananjay?
Thank you, Nathan. I would once again like to thank each and every one of you for joining us today for this presentation. I'm sure you would definitely find this presentation useful. So let's get started. Cloud migration journey. In the era of cloud computing, almost every organization is looking for migrating applications to the cloud. And one of the key steps in cloud migration is migrating the data from on-premises systems to the new system in the cloud. Cloud migration could also be needed when the application is re-architected to take advantage of the newer technologies. Cloud migration of application goes to several different stages in its journey to completion. Stages in the cloud migration varies based upon the type of the application and the experience of the organization handling the migration. So what are the different stages in this journey? Organization identifies the driving factor for the migration. Some assessment have to be conducted to check the support, technology coverage, security measures, and cost of the cloud provider. POCs needs to be conducted to find out the feasibility of migrating the various applications. Then the organization goes through the procurement phase. Then the organization has to think about the way to migrate the application and associated data to the cloud. I will skip the data migration stage for now. We'll come back to it in a few seconds. The application migration typically goes through plan, migrate, test, and monitor phase. The journey then finally enters into the maintenance phase, which involve optimizing and enhancing the migrated application. And this phase could be ongoing phase for some of the applications which incur frequent changes. Coming back to the data migration. So it could happen, the data migration could happen right before the application migration, or it could happen in tandem with the application migration itself. It really depends upon the timeline of migrating that particular applications to the cloud. In most of the cases, it's always in tandem with the application migration because it's a boom of agile development right now. Today's presentation is focused on the data migration phase of this whole cloud migration journey. So we're going to focus on our experience in this particular domain and as how we as a Bitwise can help in this important phase of cloud migration journey with our core accelerator service. When it comes to data migration, there are many things to consider. For example, conversion of source schema to the target schema, conversion of unsupported data types on target database, structured versus unstructured data, schedules, timings, loads, history versus current real-time data migration, full load versus change data capture, validation of migration data, etc. So without further ado, let's get into the data migration in details. Before talking about how, let's talk about various challenges organization may face in data migration. Even with the availability of the advanced tools and technologies, data migration may not be seamless and may require lots of manual efforts. What you are seeing on the screen are some of the challenges faced during data migration. Though this seems common, they pose unique risks based upon the context of the data being migrated. I am not going to talk about all of these challenges in interest of the time, but if you would like to know more, you can always reach back to us on the contact details provided later in this presentation. Let's talk about few of them. Load on the source DB. You could ask why this is a challenge. Most of the time, when data migration is happening, the application that is being migrated may be live in production serving the customer. The data migration to the new system is expected not to impact the existing system, which we all know how hard it could be. When there is a timeline to meet for a new project, it could further complicate the migration. The another thing is the manual intervention. Manual interventions could required in the data migration process, and it could take lots of man hours away from the project. Some of the steps where manual efforts would be needed will be scheduling, source to target schema conversion, data type mapping, configuration of the migration process, doing some validations manually, etc. The other challenge could be change data capture, and especially in the environment where the data is changing continuously. We all know how the change data capture, which is also called CDC, could be a pain, even when it is done on the databases of the similar type. Imagine the difficulties if the source and the target DBs are not the same. Some databases may not even have the built-in support for the change data capture. Running change data capture can also impact performance of the source system. Finding the right sets of attribute for every table that needs CDC could be trivial, time consuming. The other challenge that you could face is the data validation and the efficiency of the data validation. Once the data is migrated, validating the data for migration accuracy is really important for the data consistency. Though there are tools in the market which could help in validating the data in target by comparing it with the source, often these tools need lots of manual intervention and they may not be forgiving to the source database in terms of load. The another and more challenging or kind of a challenge which is like we all know is pipeline failures and the restartability. It involves lots of lost hours in the manually finding the issues, correcting the issues, and restarting the pipeline. So similarly, there are other challenges like integrating with the source and the target system so that there could be another automated process that needs to run after the migration is complete. Um, if you have a systems which is distributed over multiple databases, migration of the data for that multi-source distributed database could be another challenge. So when we talk about these challenges, there has to be some solution, some recommended ways to migrate the data. So let's take a look at some of the recommendations to overcome these common challenges. So that some of the recommendations that we came up with from our experiences are: design the migration process in a such a way that the process can be throttled. Throttling will help you keep the load on the source database optimal. This is really important if you still have users on the source system and there is no downtime you can find to migrate your data. Look for minimal manual intervention to minimize the manual errors. Something that could easily come up with the migration configuration by scanning the source database and suggest the best possible schedule to migrate the data. Validation of migrated data is really important to maintain the data consistency. Usually full validation, which involves row to row mapping, takes really long time when you have terabytes of data. Try to have sample validation, which would have some indicators upfront, followed by full validation. Migration of the data could be a lengthy and long running process. Simple network glitch could cause the data migration process to error out and start over. Having the fault tolerant process, which would make several retries before erroring out, and having the process which can be restarted from the point it encountered error, comes really handy in these kind of situations. Data migration process should be able to migrate the data in full at any given point in time. Along with that, when the source system is live, the process should be able to detect the changes and should be able to migrate the data next time it runs. Having a data migration process which can integrate with the messaging framework is a plus. This helps you automate the task on the other system which are dependent upon the data migration. When it is needed to lift and shift the data without re-architecting the application, having a tool to generate the schema for the target database reduces lots of manual work. It is more helpful in cases where the target database and the source database have incompatible data types. Similarly, there are other considerations like ease of monitoring the migration, security of the data that is being migrated, integration with data catalogs, logging, sending success and failure notifications, and creating the reports which can be used for auditing. So while working for various clients throughout US and UK in helping them migrate their applications and data to the cloud, Bitwise closely monitored these challenges and the actions that was taken to overcome them. The recommendations we just went through were the outcome of that learning. We didn't stop there. We went ahead and tried to automate the recommendations to minimize the human errors in the process. And that's how the Bitwise data migration framework was born. Before getting into the details of the framework, let's see the overall data migration flow. Excuse me. Uh, let's see the overall data migration flow in the Bitwise data migration framework. So the first step in the migration is to get the system ready for the migration. Schema generator utility scans the source database and collects the metadata like primary keys, load mode, the size of the table, the watermark columns which will be used for the change data capture, etc. It also generates the schema for the target database along with the DDL script. Generated DDL can be easily deployed to the target database as is. The next step is to migrate the historical and incremental data. There are three sub-steps in this step: extraction, tokenization, and load. Extraction process takes care of automatic source to target data type conversion. Historical data is loaded first, and once the historical load is done, the delta or the incremental load starts. Values in the watermark columns are used to capture the changed or added rows for CDC. Tokenization is an optional stage and can be skipped if not required. And the last step is the validation. A quicker hash validation is executed before running full validation, which could identify the issues quicker. Full validation then generates the detailed report, which would help identify the migration issues. For the huge tables, System auto detects all the partition on the table and start the migration process partition by partition. For each partition, a separate migration process is created and multiple processes are run in parallel to speed up the load. Throttling mechanism is used to control the number of parallel loads, which could further optimize the load on the source and the target databases. This framework makes use of the various tools already present in the market from the cloud providers for the data migration in conjunction with the tools developed by Bitwise in-house to fill the gaps. It has already gone through various trials and evaluations at our various clients, and it has proven its success. Let's take a sneak peek into the heart of this successful solution. This is the detailed architecture of Bitwise data migration framework. On the left-hand side, you see various data sources supported by this solution. It includes, but not limited to, the relational databases like MySQL, SQL Server, Oracle, big data, big data databases like Teradata, Netezza, various flat file format like CSV. It also supports the compressed files. On the far right, you see some of the major supported databases as a target. Google BigQuery, Snowflake, Amazon Redshift are some to name the few. Second big box from the left lists the components of the Bitwise data migration, which executes on the Kubernetes cluster. It is divided into two logical units. First one, which actually transfers the data, whereas second is the logical unit which controls the data migration process. Within data transfer units, there are different pods for the extraction, tokenization, load, and validation. Within the control unit, there are pods for scheduling, throttling, logging, etc. Third big box from the left lists the cloud provider native tools. This solution uses to complete the data migration efficiently. It ranges from various monitoring features different cloud provider provides to the frameworks like Spark. The Spark, the Spark cluster is usually used for data validation after the migration is complete. Example of typical data migration supported by this solution includes data migration from on-premises files to cloud databases, any on-premises or the cloud databases to any other cloud databases. And there is another phase which is in development right now, which is going to support data migration from on-premises files to any cloud storage like GCS, Azure Blob Storage, AWS S3, or the SFTP server. Some of the key features provided by solution which is powered by this architecture include multi-thread data migration for big databases, monitoring, validation, configurable throttling via different types of throttling algorithms, summary reports for every migration at the end of the migration, support for data tokenization, and out-of-the-box scheduling. Like any other tool, it also needs some configuration, which includes setting up the audit database. This audit database could be on premises or on the cloud. It needs working Kubernetes cluster. Again, it could be on premises or cloud. Setting up the VPC for the secure data transfer, setting up the secure tunnel from source to the VPC, and optional SSL setup. So all this time we were talking about this framework. Now it is time to see it in the action. Let me take you through the demo of Bitwise data migration framework, migrating the data from Teradata to AWS Snowflake. This is just one of the use case that we have. There are various other use cases we have. You can reach out to our sales department to see the demo for the use case associated with which you are interested in. So let's get into the demo. So this is the source database, Teradata database, which is being migrated to the Snowflake. It has two databases, finance and the payroll. Framework supports a wide variety of the databases as source and target. Next is the configuration database. This database is the brain of the migration framework, which control all the stages of the migration, starting from identifying the CDC attributes to execution, schedules, and errors. Most of the tables in the config databases would be empty at the beginning. They will get populated automatically later when the config generation step is executed. A group table in the config helps to make a logical group of the tables, which can be migrated individually or in the groups. The next step is generating the config and the DDL for the target Snowflake database. As soon as this step is executed, the previously empty config database will get populated with the default configuration generated by scanning the source database. This step also generates the DDL script for the target database. A next step is getting the target database ready for migration. If you see databases are empty and no tables are present under them, the DDL script that was generated during the config generation step can be used to get the database ready and the right set of tables. Framework maps the data types from the source database to the best possible types in the target without any manual intervention. And as discussed earlier, framework has support for almost all the major cloud databases in the market. Config generation step also generates the best possible schedules as to when these migration jobs should run based upon the data in the source database. These schedules can be modified if needed. The migration can be triggered from UI2, which is what we did for this particular demo. Migration for each group can be individually triggered from the UI. There is also an option of triggering these jobs via REST endpoint. That means you can use your own scheduler to schedule the migration as long as it supports triggering the jobs via HTTP call. UI shows the real-time stats of the migration in easy to understand form. It shows the status of each and every table that is being migrated along with the step it is executing for each table. As and when each step is executed, respective log is streamed to log provider in real time. The logs that you are about to see on the screen are the logs streamed to the AWS CloudWatch. You can slice and dice the logs to see exactly what process is doing at a particular point, along with the exact queries framework has performed to complete the work. Separate logs are created for every table that is being organized, which further makes it easy to troubleshoot the issues. These detailed logs can be exported for auditing purpose. It is really important to hook the data migration process to the source and the destination applications through some kind of event-driven architecture. This enables automatic data migration from source to target system based upon the predefined or predetermined event and reduces the manual intervention, which could be error prone. This integration with source and target application could be further complicated if two systems are completely on different platform and technologies. Data migration framework can publish the messages to the message queues, which can be consumed by various applications or the systems to further automate the workload which are dependent on the migration. So once the data migration is complete, the validation is performed and the status of the validation will be available on the UI along with the option to download the detailed validation result. So this was the quick demo of data migration framework. Please feel free to reach out to our sales team if you would like to know more about the data migration framework along with a detailed demo relevant to your needs. Thank you again for your participation in this webinar today. Back to you, Nathan.
Great. Thanks, Dhananjay. As you can see, Bitwise brings extensive experience in data movement in the end-to-end data lifecycle. Combined with our partnerships with leading providers such as Google, AWS, Microsoft Azure, and Snowflake, we're well positioned to help you create a modern BI solution. Whether you are exploring use cases or evaluating tools, or just need help building your strategy and roadmap, Bitwise can help. Contact us at sales@bitwiseglobal.com to explore strategy assessment options or get a deep dive into the solution we just presented. Before we move into the Q&A, I want to thank you for taking time for joining us today.